Imagine a universe where Earth is no longer the solitary blue gem, but instead dances as a tiny moon orbiting a colossal gas giant. Its clouds swirling in a kaleidoscope of color, casting enormous shadows across a landscape that's both familiar and alien. From this vantage point, our world would be reduced to a shimmering speck, a fragile satellite caught in the enormous gravitational embrace of a vast planet, revealing a universe where beauty and scale redefine everything we know. Watching this, you'll see how such a cosmic shift would transform not just the sky, but the very essence of life, light, and mystery, inviting you to step into a different perspective, where the universe's grandeur is both humbling and breathtaking. The cosmic wake-up, Earth's hypothetical transformation. If Earth had become just a moon orbiting a colossal gas giant, the very fabric of our perception of space would shift dramatically. To begin with, the size differential alone is staggering. A gas giant's diameter can be hundreds of thousands of kilometers larger than Earth's modest 12,742 kilometers. From the surface of a hypothetical Earth moon, the sight overhead would command awe, an immense swirling mass of clouds, storms swirling in mesmerizing chaos, and bands of color wrapping around an enormous glowing sphere. The planet's massive gravitational pull would tether Earth tightly, causing tides that rhythmically lash at its shores with immense power, much more forceful than anything seen today. The light would be a spectacle in itself. The gas giant's thick atmosphere, composed mostly of hydrogen and helium, would diffuse sunlight in unpredictable ways, casting surreal, shifting shadows across the lunar surface. The familiar blue sky would be replaced with a perpetual glow of distant storms and auroras fueled by the planet's magnetic field. The moon's night sky would be dotted with bright, swirling clouds of gas and the faint illumination of the planet's luminous banding, making the stellar canvas less sharp but more mystical. Earth's distant star, the Sun, would appear as a tiny, almost unnoticeable flicker, lost beneath this vast, swirling spectacle. Gravity would be an entirely different experience. Earth's gravity, roughly 9.8 m/s superscript 2, would be overwhelmed by the planet's immense pull, meaning the moon would cling tightly to its larger sibling. Walking across the surface might feel tethered, as if gravity itself were pulling in all directions at once. The gravitational tug might also influence the moon's internal structure over millennia, possibly leading to tectonic stresses and a more dynamic, if chaotic, geology than we know today. Rain suppresses, and winds carry particles across the lunar landscape, creating dust storms of cosmic proportions, constantly reshaping the terrain in a slow dance with the planet's gravity. This scenario would be divorced from Earth's familiar serenity. Instead of a lush, life-sustaining oasis, the moon would be a stark, mesmerizing place. Its landscape contrasted sharply against the backdrop of the gas giant's swirling storms. Every sunrise and sunset would be a cosmic pyrotechnic event, with fleeting glows that dance across the surface as storm systems eclipse the planet's bright bands. The relentless beauty of such a celestial relationship would redefine scale and perspective, where Earth is no longer the center of its universe but a tiny, dependent shard of a grander, more tumultuous cosmic ballet. Genesis of a gas giant's moon. The formation of a moon around a gas giant begins long before the planet's grand presence fills the cosmos. These enormous planets, composed predominantly of hydrogen and helium, gather a vast, swirling disk of gas and dust during their infancy, remnants of the nebula from which they coalesced. Within this circumplanetary disk, tiny particles collide and stick, forming increasingly larger fragments through a process known as accretion. Over time, some of these clumps grow massive enough to become gravitationally dominant, carving out their own small zones of influence amidst the chaos of the disk. In this swirling environment, the boundaries between creation and destruction blur. Dust particles spiral inward, dragged by the dominant gravity of the new gas giant, while others coalesce into moonlets, embryonic moons still drifting within the disk. These moonlets are shaped by a complex interplay of gravitational attraction, angular momentum, and electromagnetic forces. Some are torn apart by tides or collide with each other, while others manage to survive and grow. Each collision, each accumulation, imprints a history of chaos and calm, a testament to the relentless sculpting power of gravity. What might be truly awe-inspiring is the scale and beauty of this process. Around a colossal gas planet, The newborn moons are tiny specks compared to their parent, yet they dance around an intricate, gravitational choreography. In the shadows of the planet's gas envelopes, a moon might be born from the residual debris, emerging as a radiant sphere bathed in reflected light and shadowed by swirling clouds. As these moons grow, their surfaces become battered with impact craters, reminiscent of a storied past etched into their rocky or icy shells, each scar marking a piece of their turbulent genesis. This process is a profoundly dynamic ballet of cosmic proportions. The gravitational forces that form these satellites are so vast that they can shape the very orbit and internal structure of these moons. Some may develop thick atmospheres from captured gases, while others remain icy and barren, frozen in time. The sheer scale of these interactions, measured in thousands or millions of kilometers, emphasizes their grandeur. These moons, born of chaos and stitched together by gravity, embody the majestic, often chaotic poetry of planetary system formation, setting the stage for a universe teeming with countless worlds, each with its own story woven into the fabric of cosmic history. The formation and capture of Earth. Imagine a cosmic ballet where Earth, a vibrant blue sphere shimmering with swirling clouds and vast oceans, drifts through an extraterrestrial woo of gases and distant stars. In this scenario, Earth is not a solitary planet but a moon, captured by the gravitational embrace of a massive gas giant, similar in scope to Jupiter or Saturn. Its formation in such an environment would hinge on complex gravitational interactions, a dance choreographed by the early chaos of the solar system. During the chaotic infancy of a planetary system, planets and celestial debris jostled within a turbulent cloud of dust and gas. Earth likely formed from accreting material, rocks, metals, and ice, through a process that gradually built up a substantial core. However, instead of settling into an independent orbit, it could have wandered into the gravitational sphere of a nearby gas giant during this tumultuous period. A close encounter would cause the gas giant's gravity to influence Earth's velocity and trajectory. Capture would occur if Earth passed within the gas giant's hill sphere, the region where its gravitational influence dominates over the Sun's. In a delicate gravitational tug-of-war, Earth's velocity relative to the gas giant would need to match a specific range, neither too fast nor too slow, for it to become a permanent satellite. This process might resemble a cosmic handshake, where Earth's momentum is gently siphoned by the gas giant's immense gravity, causing it to slow down and settle into a stable orbit. The presence of a dense planetary envelope or a surrounding disk of debris might facilitate this capture. As Earth lost kinetic energy through tidal interactions or friction with dust and gas, it would spiral inward, ultimately settling into a relatively stable orbit around the gas giant. This scenario transforms Earth from a separate planet into a moon, one shaped by the gravitational complexities and the luminous beauty of its new host. The capture process would be fleeting but powerful, a moment when cosmic forces align in an intricate, poetic display, forever changing Earth's identity in the grand dance of celestial mechanics, altered orbital dynamics and tidal forces. Gravity's dance becomes a grand spectacle when Earth takes on the role of a moon orbiting a gas giant. In the cosmic ballet, the relationship between celestial bodies is governed by the intricate physics of orbital dynamics and tidal forces, and these rules transform dramatically under this scenario. Instead of gliding through the solar system as a relatively stable planet, Earth would be caught in a complex embrace with a massive, swirling gas giant, perhaps Jupiter or Saturn, shifting the gravitational landscape into a wild, intricate choreography. The mass difference is dramatic. A moon of a gas giant might experience a gravitational pull that is orders of magnitude more intense than what it does from the Sun. As a result, Earth's orbit would not be a gentle ellipse, but a tumultuous path shaped heavily by the gravitational tug of its gaseous master. Tidal forces would escalate to monumental levels, profoundly shaping both the planet's surface and its internal structure. The gravitational gradient, the difference in gravity between the side facing the planet and the opposite side, would stretch Earth into elongated shapes during each orbit. The Moon, or in this case Earth, would undergo constant flexing, generating massive internal heat through tidal friction. This ongoing flexing could ignite volcanic activity and reshape its crust, transforming continents into stormy, ever-changing landscapes. On top of that, the orbit itself might become highly eccentric, causing Earth to swing closer to and farther from the gas giant in a looping dance that affects everything from climate stability to the very habitability of life. Viewed from afar, the environment would be utterly mesmerizing. A gas giant swirling storms and luminous cloud belts would cast an ethereal glow, illuminating Earth's surface with flickering light filtered through an ever-changing mosaic of gas and cloud. Close enough, the gravitational tug would cause visible curvature on Earth's oceans, creating gigantic tides. Equally awe-inspiring and destructive, these tides would be synchronized with the gas giant's rotation, meaning the water levels could fluctuate dramatically as Earth spirals through regions of varying gravitational strength. Imagine standing on a shore witnessing the relentless rise and fall of tides so powerful they could rearrange coastlines in a matter of hours. Meanwhile, from Earth's surface or orbit, the combined effects of altered orbital mechanics and tidal forces would forge a landscape of relentless change. The orbital path might be destabilized by the gas giant's gravitational influence, forcing Earth into a series of chaotic, often unpredictable orbits. Seasons could become erratic, with tidal locking or near-locking phenomena producing harsh, protracted days or nights. The beauty of the scene, giant planet clouds swirling, tidal cracks splitting continents, shimmering tides, would serve as a testament to the profound influence of gravitational forces at play, transforming the serene picture of a planetary orbit into a dynamic, living artwork crafted by the relentless grip of a gas giant's gravity. Earth's new atmosphere and climate dynamics. If Earth orbited a colossal gas giant, the atmosphere that once nurtured life would undergo a profound transformation, shaping an alien climate as breathtaking as it is alien. The planet, nestled in the shadow of an immense, swirling tempest of clouds and storms, would have its atmospheric composition radically altered by the gas giant's influence. Instead of the nitrogen-oxygen mixture familiar to us, Earth's atmosphere might resemble a layered mosaic of gases, with thick clouds of methane, ammonia, or other hydrocarbons swirling across its surface, casting shifting shadows and diffusing light in peculiar ways. This altered atmosphere would likely be denser overall, pressing down with greater weight and creating unfavorable conditions for traditional life forms. Yet in this haze, certain life forms or phenomena might adapt or even thrive, living in the shadows or in pockets shielded from overwhelming gases. The warmth and light reaching Earth would become less direct, more diffuse through the opalescent curtain of gas. The gas giant's massive body would block or reflect a significant portion of stellar radiation, creating a cold, dim environment. Yet in some regions, where cracks in the gaseous shroud allow glimpses of starlight, fleeting glimmers could trickle down, casting ephemeral illuminations over the surface. The climate might be dominated by turbulent, cyclical storms, where intense jet streams and vortexes distribute heat unevenly. This constant churning could result in climates of extreme variability, with localized patches of relative stability that serve as refuges amid chaos. Seasons could hinge on the gravitational tug of the gas giant's once invisible pull, tugging Earth closer or farther from its star in rhythmic, millennia-long cycles that disturb weather patterns and ocean currents alike. Light itself would dance differently, scattered and scattered again, creating an eternal twilight under a veiled sky. The atmosphere might filter stellar light into surreal hues, emerald green, violet, or fiery orange as gases absorb, reflect, and bend radiation in complex ways. Extended periods of darkness could ensue during the giant's shadow passes, punctuated by brief flashes of brightness when the planet's orbit aligned favorably. The lush, blue skies of present Earth could give way to a perpetual, mesmerizing twilight, where the horizon blurs into a canvas of shifting colors and diffuse luminescence. Wind and weather systems would be shaped not solely by Earth's rotation, but also by the gravitational flexing exerted by the gas giant, creating a climate of perpetual flux, spectacular, unpredictable, and profoundly alien. In this scenario, the delicate balance of Earth's climate system would give way to a spectacle of cosmic forces, where gravity, gas, and light entwine in a dance older than our understanding. The atmosphere's composition, density, and turbulent dynamics would determine whether life could cling on or simply fade into obscurity. The beauty of such a world wouldn't lie only in its alienness but also in its resilience. How it could sustain pockets of life amid such chaos, or how the shifting gases and radiant hues could craft a new poetry of existence on a planet no longer quite Earth, yet still holding on to the faint echoes of its blue-green past. Surface transformations and geological impact. If Earth morphed into a moon orbiting a colossal gas giant, the very landscape we know would undergo dramatic, almost surreal transformations. The gravity exerted by such a giant would tug relentlessly on Earth's crust, causing it to compress and flatten in ways that defy current geological expectations. Instead of the familiar continents and mountain ranges, the surface would be sculpted into gently undulating plains or deeply fractured terrains, shaped by gravitational stresses pulling in multiple directions. Mount Everest's towering majesty, for instance, might be smoothed out or broken into fractured debris, losing its dominance amid a surface constantly in flux. Cracks and fissures would become prominent, carving deep scars into the landscape, reflecting the relentless weight pressing down from above. The heat generated by intense tidal forces would awaken dormant geological processes. Friction within Earth's crust would produce local heat pockets, fueling volcanic activity even in regions that are currently considered geologically quiet. Lava flows might seep out from mantle pockets or fissures, creating new landforms and filling in cracks with glowing, molten rivers. These eruptions could reshape entire regions, blending the boundaries between oceanic and continental zones, and offering bursts of fiery beauty amid the cold vastness. The surface would be dotted with volcanic islands, shimmering with volcanic glass and ash clouds billowing high into the atmosphere, illuminated by reflected light from the gas giant's swirling cloud tops. Erosion processes on such a moon would also differ profoundly from what we experience on Earth. With the absence of weather systems driven by an atmosphere like ours, erosion might predominantly occur through ongoing tectonic shifts, volcanic activity, and subtle interactions with the local stellar environment. If the gas giant's reflected light is intense enough, some surface features could be weathered by thermal expansion and contraction cycles, frosts and thaws driven by the distant star's warmth, supported by residual geothermal heat. Over eons, these processes could produce layered sediments, new mineral deposits, and crystalline formations that shimmer with otherworldly hues. Light and shadow would dance across the surface in extraordinary ways. Bright reflections from the gas giant's cloud tops might cast shimmering glow across tectonic scars, while shadowed valleys hide unspoken secrets of a constantly changing landscape. The surface would be a mosaic of chaos and beauty, constantly rewritten by gravitational ballet, volcanic fury, and subtle planetary forces. A celestial canvas where the imprint of cosmic forces would be etched into every ridge, crater, and fissure. An awe-inspiring reminder of the universe's raw power and artistic grandeur. Day-night cycle under a massive gas cloud. Beneath the swirling, tumultuous layers of a colossal gas giant, Earth's surface would be shielded from direct sunlight, transforming the familiar rhythm of day and night into a mysterious, shadowed ballet. Instead of a bright, glaring sun, the only light filtering through the dense, opaque clouds would be diffused, scattering in countless directions with a softness that blurs the boundaries between day and night. A faint, permanent glow, perhaps from the planet's internal heat or reflected light from the gas giant's enormous atmosphere, would provide a subtle illumination, creating a persistent twilight that never fully yields to darkness or brightness. The dense, swirling cloud tops of a gas giant are made up of stacked layers of gas that extend thousands of kilometers into the atmosphere. These layers form a natural barrier, absorbing and scattering sunlight so thoroughly that the concept of a clear, defined day becomes almost irrelevant. Instead, the surface beneath this cloud cover experiences a constant, muted glow that ebbs and flows with the turbulent movements overhead. Some regions of the cloud may occasionally part to allow brief glimpses of light, either from internal heat escaping from within the planet or from distant moons reflecting scattered light, offering fleeting moments of clarity amid an endless, diffused gloom. Gravity plays a crucial role here, pulling everything toward the planet's core, while the thick cloud layers keep direct solar rays at bay. The gravitational influence of the gas giant ensures that, despite the lack of direct sunlight, the moon's surface remains warm enough to sustain complex weather patterns, with storms and vortexes twisting beneath the cloudy canopy. These atmospheric phenomena generate their own light. Glowing auroras and electric storms crackle across the cloud tops, creating bursts of vivid color in the perpetual dimness. Such displays would paint an ever-changing gallery of luminous chaos, an atmospheric symphony that defines the illusion of day for any surface observers far below. From this vantage point, the concept of time becomes fluid and surreal. Instead of a predictable cycle of sunrise and sunset, the inhabitants or explorers on this moon would experience a landscape bathed in semi-darkness, punctuated by ephemeral flashes of light that flicker unpredictably through the maelstrom above. Light levels might fluctuate daily, but never in the straightforward manner we're used to. Instead, they would mirror the chaos of the gas giant's turbulent storms, creating a rhythmic pattern defined more by atmospheric shifts than by celestial mechanics. The dark patches and glowing cloud formations would weave an intricate tapestry that hints at the immense scale and beauty of the gas giant, reminding all who look up that even beneath a shroud of darkness, the universe continues to pulse with energy and wonder. Possible biological implications and life scenarios. Beneath a colossal gas giant's swirling bands, a moon might drift in a silent world of shadows and light, where sunlight is a fragile whisper filtered through thick, luminous clouds. The biological implications of such a scenario are staggering. Life would need to adapt to extremes of energy and gravity, forging existence in conditions vastly different from Earth's familiar cradle. With the gas giant's immense gravity, the moon's surface would experience a gravitational pull significantly stronger than our own, reshaping how lighter life forms grow and move. Imagine organisms that evolve robust structural frameworks to withstand the intense pull, massive, dense, perhaps even crystalline in their biology, designed to resist being torn apart or crushed by the relentless force. Light would be a scarce treasure, a faint glow cast through thick atmospheres of methane or ammonia, illuminating a world where photosynthesis might be driven by unusual pigments absorbing narrow bands of light, or even by chemosynthesis along deep-sea vents. These vents, perhaps closer to the moon's core or hidden beneath layers of ice, could become cradles of life. Chemosynthetic organisms, akin to those near Earth's hydrothermal vents, would harness chemicals like sulfur compounds or methane, creating an ecosystem based on chemical energy rather than sunlight. Such ecosystems could be expansive, thriving in hidden valleys or beneath icy crusts, offering a glimpse of how life might persist in environments with minimal light. The beauty of such a world lies in its diversity and resilience. Biological life might develop unique adaptations to cope with a variable climate and high-pressure environments, possibly growing in sprawling mats, massive microbial colonies, or even complex multicellular entities that resemble strange, alien forests. The possibility exists for life forms that utilize structural advantages afforded by the moon's gravity, allowing for towering, elongated shapes, or twisting, multilayered forms optimized for nutrient absorption and protection against radiation or chemical toxicity. If life finds a way to flourish there, it would be a testament to evolution's tenacity, shaping habitats where energy becomes a scarce but fiercely fought resource. Evolutionary pathways would diverge drastically from Earth's, guided by a relentless interplay of light, gravity, and chemistry. Given the thick atmospheres and distant sun, the biosphere might rely heavily on chemical signaling, bioluminescence, or even unknown energy channels permeating the volatile depths of the moon's environment. The consequences for heredity and nuclear stability could mean a slower pace of evolution, yet one filled with strange innovations. Ultimately, life in this scenario would be a fragile but persistent mosaic, shimmering in the shadows of a gas giant, an echo of resilience amid cosmic grandeur. Gravitational effects on the gas giant structure. A moon orbiting a gas giant introduces a fascinating dynamic that significantly influences the giant's very fabric, its shape, and internal structure through gravitational interplay. Unlike the relatively stable moon-planet systems we observe in our own solar system, where the moon's gravitational tug subtly shapes tides and orbital paths, a planetary satellite on a much larger scale exerts forces capable of reshaping the gas giant at its core. The immense gravity of the moon, especially if it were comparable in size to Earth or larger, would tug gravitationally at the gas giant's outer layers, creating a constant, shifting balance of forces that ripple through the planet's vast, gaseous envelope. The tension between the two bodies would produce pronounced equatorial bulges, warping the planet's shape far beyond simple spherical symmetry. The gravitational pull from the moon causes a deformation that, depending on proximity, could make the gas giant resemble an oblate spheroid more extreme than anything observed in our solar system. For instance, Jupiter's oblateness, caused by its rapid rotation, would be further exaggerated if a massive moon pulled on its equatorial regions, causing distortions akin to a celestial dance choreographed by gravity itself. But the effects wouldn't just be skin-deep. The internal pressure gradients and convective currents within the planet's layers would mold themselves around these gravitational distortions, creating complex internal patterns. At a deeper level, the gravitational tug of the moon would influence the gas giant's internal stratification. The pressure and density distribution might shift, leading to potential zones of turbulence or even internal resonances that could alter heat distribution. These effects could ripple inward, subtly shifting the planet's magnetic field lines as well. Since many of the gas giant's magnetic properties stem from dynamo effects within metallic hydrogen layers, caused by the interaction of gravitational forces and hot, conducting interiors, the result might be a planet with a magnetic field that doesn't just wobble predictably, but fluctuates in response to the moon's orbit, adding another layer of complexity to its already mesmerizing aura. Gravity's influence would extend toward the planet's atmospheric features too. The gravitational deformation, coupled with the moon's orbit, might generate persistent atmospheric storms or wave patterns, akin to giant tides within the gaseous envelope. Large-scale cloud formations could be subtly shifted or intensified by these ongoing gravitational tides, creating a ballet of swirling gases and shimmering lights that dance across the planetary atmosphere. The phenomenon would resemble a complex symphony of gravity, light, and turbulence, sometimes calm, sometimes fierce, highlighting how interconnected celestial bodies are when they exist in such delicate, gravitationally bound relationships. The beauty of this system, viewed from afar, would be a testament to the immense and often unseen forces shaping worlds on scales both grand and intimate, echoing the raw, awe-inspiring power of the universe itself. Potential for moons and ring formation. If Earth had become a moon orbiting a massive gas giant, the landscape of possibilities for additional satellites and rings would stretch into grandeur that defies everyday understanding. Imagine the colossal gravitational influence wielded by a gas giant. Its immense pull could trap remnants of cosmic debris, creating a shimmering, swirling disk of dust and ice. This debris could gradually coalesce into smaller moons, each tugged by gravitational intricacies into stable, sometimes eccentric orbits. In some regions, tiny rocky or icy fragments might be captured temporarily, forming a chaotic but breathtaking ring system reminiscent of the majestic displays around planets like Saturn. These rings would not be static. Instead, they could oscillate and evolve, constantly reshaped by gravitational interactions, collision cascades, and the subtle influence of solar radiation. The scale of such a system would dwarf anything seen in current planetary architecture. The gas giant's gravity would extend its influence far beyond Earth's current orbit, creating zones where the tug of gravity keeps particles suspended in delicate web-like formations. As the dust and ice particles collide and bounce, they would generate a kind of cosmic ballet. Some fragments might grow through accretion, forming new moons or ringlets over millennia. Others, dislodged or shattered by impacts, would perpetually replenish the ring's shimmering mass, casting a multicolored glow that flickers in the planet's subdued light. The beauty of this celestial spectacle would lie in its ephemeral, ever-changing nature, an ongoing sculpture carved by gravity and particles dancing in harmony. In this scenario, the potential for a diverse collection of natural satellites would be tremendous. Smaller moons, born from the debris within the gravitational influence, could vary drastically in composition and appearance, some icy and reflective, like tiny mirrors catching the gas giant's sunlight, others darker and rocky, less bright but equally mysterious. The largest among them might orbit at respectful distances, taking years or even decades to circle their host planet. Their surfaces could teem with impact craters, ancient scars from cosmic collisions, and perhaps even cryovolcanoes spewing icy plumes into space. Each satellite and ring element would contribute to a layered, complex system, an artistic mosaic woven beneath the vast, swirling canopy of the gas giant overhead. All these possibilities underscore the sheer scale and poetic grandeur of a planetary symphony where Earth becomes but a single note within an orbiting ensemble. Light from the star would filter through the gas giant's thick, swirling clouds, illuminating rings that shimmer with pristine ice and darker shadows, creating an ever-shifting interplay of brightness and obscurity. It would be a universe alive with motion and mystery, where gravitational forces sculpt beauty on a cosmic scale. The potential for moons and rings in such a scenario sketches an awe-inspiring tableau, one where nature's chaos gives birth to harmony, and the universe itself seems to sing in rings and satellites, an eternal testament to gravity's poetic power. Impact on the solar system's balance. If Earth somehow found itself as a moon orbiting a colossal gas giant, the repercussions would ripple through the delicate dance of celestial bodies with hauntingly beautiful consequences. The gravitational harmony that currently governs the solar system relies on a complex interplay of mass, distance, and momentum. Earth's status as a planet, a primary hub of life and activity, contributes to a predictable gravitational pull that influences nearby asteroid belts, the orbits of neighboring planets, and even the distribution of minor objects in the Kuiper belt. Reconfiguring Earth into a moon would radically alter these relationships, forcing many orbits into new, unpredictable patterns. The size discrepancy would be staggering. A gas giant like Jupiter or Saturn is many times the mass of Earth, enveloping its core with swirling, luminous clouds and a vast, tempestuous atmosphere that radiates immense light. Earth's previous heft vanished, replaced by a fragment orbiting at a distance where the heat and magnetism of the gas giant dominate. Such a shift would mean Earth's gravitational influence shrinks dramatically. It would no longer shepherd debris or influence space objects in quite the same way. Instead, it becomes a mere satellite amid a tumult of swirling gases, a fragile, shimmering moon cast in the massive shadow of its planetary parent. This transformation would also send shockwaves through the orbital stability of other bodies. Some asteroids and comets that once skirted the solar system in a predictable manner might now encounter altered trajectories, pushed into new paths by the reconfigured gravitational tapestry. The asteroid belt, for example, might experience increased chaos, or even some of its objects diverted inward, potentially crossing Earth's previous orbit. Over millennia, such shifts could jeopardize the safety and stability of other planets, subtly disrupting the balance that has persisted for billions of years. The quiet, spectacular alignment of planets, its synchronized ballet, would inevitably become more chaotic, with slight variations compounding into unpredictable movement patterns. Moreover, the gravitational tug of a now moon-sized Earth could influence the gas giant itself. While a single moon is unlikely to cause noticeable destabilization in a massive planet, a large, close-by satellite can generate tidal effects in the atmospheric clouds, leading to complex interactions that might intensify storm formations or alter cloud patterns. These disturbances could ripple outward, affecting the planet's magnetic fields and even its internal heat flow, subtly tweaking the entire planetary system's energetic balance. Yet, the grander consequence remains the shifting equilibrium of the solar system's architecture. An intricate, beautiful chaos rooted in gravity's silent, relentless push and pull. The cosmic symphony, in this new configuration, would resonate with a different tone, more unpredictable, more fragile, yet infinitely fascinating to behold. Human perspective. Reimagining Earth's identity. Without the protective embrace of our sun's warmth and light, Earth's identity would shift radically from the vibrant blue and green haven we know. Instead, cast as a tiny satellite orbiting a colossal gas giant, our planet would appear as a muted, shadowed orb, dwarfed amidst swirling bands of cloud and tempest that churn within the giant's atmosphere. To human eyes, such a representation would inspire a sense of awe mixed with profound humility. The luminous, fiery sun we once relied upon would be replaced, its radiance replaced by the faint glow of distant stars and the shimmering bands of the gas giant's atmosphere, which dance with strange, multicolored light during storms that seem to go on forever. From this vantage point, gravity would feel different. Earth's familiar pull, gentle yet persistent, would be dwarfed by the immense gravitational field of the gas giant, a behemoth that commands vast regions of space. Humans would feel a weightless, almost floating sensation, as if Earth itself had become a fragile leaf caught in the turbulence of a celestial storm. The horizon would stretch impossibly wide, distorted by the curvature of such a tiny moon, with the gas giant looming like an enormous, swirling canvas behind. The sense of scale would forever warp human perception. Earth's beauty, once in the foreground, would now retreat to a distant background, its continents reduced to freckles on a tiny sphere orbiting a majestic titan. Yet, paradoxically, this vision of Earth from such a distance magnifies its aesthetic wonder. Our planet, reduced to a mere speck, could still display flashes of subtle blue, hinting at oceans or faint green patches, whispering of life. The light would be dimmer, filtered through the thick, swirling atmosphere of the gas giant, giving Earth an almost ethereal glow. The contrast between the vast, storm-racked clouds of the gas giant and the fragile appearance of Earth's surface would evoke a poetic sense of vulnerability, inviting reflection on the fragile beauty of our world. It's a perspective filled with longing and reverence, a reminder that even as we drift into the cosmos, we cling to the memory of what makes Earth unique. From a human perspective, reimagining Earth as a moon of a gas giant reframes how we conceive of home and scale. Our planet's familiar features, mountains, oceans, cities, would seem infinitely smaller, yet somehow more precious, illuminated by the distant light of the massive planet's atmospheric bands. We might feel an urgent need to protect this tiny world from the tumult of a grand celestial system, even as we marvel at the grandeur surrounding it. The experience would be a humbling journey through the cosmos, where our sense of beauty and existence is forever intertwined with the immense, swirling dance of the universe, an eternal testament to the delicate, shimmering core of our universe's marvels. The philosophical and cultural shift. If Earth found itself orbiting a gas giant, the entire human perception of existence would probably be turned upside down. The familiar relationship with our planet's size, gravity, and atmosphere would shift, prompting profound philosophical questioning. Instead of being the sole cradle of life, Earth would become a luminous, distant satellite, bathed in reflected light from a colossal, swirling planet. The scale of the universe would seem even more immense. What was once considered the center of life would now appear as an insignificant, fragile orb dancing within an enormous, chaotic system. This shift would challenge centuries-old notions of human uniqueness and foster a new sense of humility, an awakening to the vast tapestry of celestial bodies that shape reality. Culturally, the influence would be staggering. Artistic expression often hinges on our relationship with the cosmos. Stars, planets, and the night sky serve as metaphors for hope, mystery, and transcendence. When Earth becomes a moon, its cultural symbolism would evolve. It would likely inspire a collective sense of awe and vulnerability. Cultures might develop new mythologies centered around the idea of being a tiny fragment in a grander planetary ballet. Religious and spiritual paradigms, which often relate to the notion of Earth's specialness, might transform to incorporate the concept of being part of a larger, cosmic family. Instead of a terrestrial paradise or divine theme, Earth could become a symbol of humility and interconnectedness, stirring philosophies rooted in the acceptance of our smallness against cosmic scales. The notions of gravity and light would also redefine philosophical perspectives. Being a moon means experiencing a weaker gravitational grasp. Human bodies and architecture would adapt, but the mental shift might be more profound. With reduced gravity, concepts of physical perfection, strength, and endurance might shift towards appreciation of fragility and adaptability. Shadows cast by distant stars and reflected sunlight would take on poetic significance, emphasizing that beauty in the cosmos is often found in subtlety and contrast rather than dominance. Light from the gas giant's swirling atmospheric storms would play across the sky, mirroring internal human struggles with the unknown, both awe-inspiring and humbling, reminding us of our fleeting existence amid eternal cosmic forces. In this new perspective, time and space could expand into philosophical realms that question the very fabric of reality. The notion of a home might evolve into a more fluid idea, less centered on terrestrial stability, and more on the interconnected dance of planetary bodies. Human identity, tied to Earth's grandeur and stability, might shift toward a collective identity within a much larger celestial ecosystem. We would contemplate our origins and future not as solitary beings, but as part of an intricate, endless universe, impermanent yet beautiful. The universe's vastness, once a distant backdrop of exploration, would now serve as a mirror, challenging us to find meaning not in dominance or control, but in harmony with the cosmic rhythm that guides the dance of planets and moons. Speculative future. Earth's evolution as a moon. If Earth had become a moon orbiting a colossal gas giant, the repercussions on its physical appearance, evolutionary trajectory, and the very fabric of its environment would be staggering. From a distance, the gas giant's swirling atmosphere, with layers of vibrant clouds and tumultuous storms, would dominate the sky, casting a diffuse, flickering light on the tiny terrestrial moon. The gentle glow of reflected light from the gas giant would create a perpetual, mesmerizing dance of illumination, shaping day and night in a rhythm divorced from our current sun-driven cycle. Tall, jagged mountains and deep, winding oceans would be dwarfed by the immense atmospheric layers swirling above, evaporating and condensing as if in a perpetual cosmic ballet. While the moon's surface would be a barren, pockmarked landscape scarred by ancient impacts, softened only by dust and ice. Gravity on this moon would be significantly weaker than what we experience now, yet strong enough to tether water and atmosphere in some form, giving rise to a tenuous environment that could support primitive life, if conditions allowed. The thin atmosphere, continually buffeted by the gas giant's powerful magnetic field, would carry charged particles and charged dust, creating auroras that stretch across the sky like luminous ribbons. Long-term evolution might see the moon's interior gradually cooling, its core perhaps thickening with precious metals that over eons could catalyze interesting geophysical phenomena. A future where this tiny celestial body develops some internal activity, volcanism or tectonic shifts, is plausible, especially if metallic core materials accumulated over time. Looking ahead, the moon's surface might turn into a gallery of complex landscapes, snow-capped peaks, vast plains of frozen mineral deposits, intricate networks of fissures, and perhaps faint signs of chemical alteration caused by isolated hydrothermal activity. Wind-driven dust storms could sweep across the surface, shaped by the subtle push of gases from the gas giant's upper atmosphere. Over vast cosmological times, it's conceivable that organic compounds, if ever they managed to form, could be sequestered in ice layers, giving rise to primitive chemical cycles. A faint whisper of life's potential in an environment so radically changed from Earth's familiar climate. The dark side of the moon would be a mystery, cloaked in shadows and silence, whispering secrets of cosmic history that unfolded long before Earth's current age. What might transpire after billions of years in this distant orbit? The moon could evolve into a complex, layered world. One that perhaps hosts rare mineral formations or even microbial life, tiny yet resilient. Its surface might become heavily cratered or paradoxically, relatively smooth if impacts decreased or if volcanic activity smoothed out rough patches. The gas giant's gravitational pull would continually influence orbital stability, causing slow but relentless shifts, an eternal tug-of-war that can reshape the moon's very shape and orbit over eons. Such a celestial dance, woven into the fabric of space, underscores the eerie beauty of a world caught in the majestic embrace of a planetary giant, fundamentally transformed but still echoing the distant origins of terrestrial life. In a universe where Earth exists as a moon orbiting a colossal gas giant, the sheer scale would redefine everything previously understood about our planetary perspective. Instead of standing on a terrestrial surface, looking into a sky filled with distant stars or the familiar void, one would gaze up to see an immense, swirling sphere of clouds and storms, with Earth a tiny, rocky speck tucked beneath its shimmering, colorful veneer. The gravitational pull of the gas giant might be hundreds of times stronger than Earth's current gravity, warping the very fabric of motion and weight. It would feel as though one is caught in a celestial dance, pulled tightly by an unseen but unmistakable force, shaping every moment. From this vantage point, daylight and darkness take on a new meaning. The planet would often be overshadowed by the gaseous envelope, creating periods of dim twilight interspersed with rare glimpses of the starry universe beyond. The light filtering through thick, multilayered clouds could cast an eerie glow, diffuse, shimmering, almost surreal. The smaller moon's surface would be subject to transient patterns of illumination, with storms on the gas giant flickering like cosmic fireworks. These storms, with their swirling, high-speed winds and massive lightning, would create a spectacle of intense beauty, a constant reminder of the powerful forces that shape gas giants. Gravity's influence would stretch far beyond just pulling objects downward. It would distort the very pathways of space and time, bending light into unusual patterns. The proximity to the gas giant might cause tidal forces, so immense that the moon's surface would be perpetually reshaped by minor quakes and shifting crusts, an ongoing geological ballet. The moon, though small compared to its parent planet, could possess its own thin atmosphere, likely composed of sidereal gases captured from the planet's intense atmospheric winds, making its surface a fragile, shimmering shell against the backdrop of a swirling chaos above. Walking there, one would feel the ground tremble subtly beneath their feet, driven by the gravitational tug-of-war between the two bodies. This cosmic setup fosters a breathtaking contrast. The fragile stability of Earth's rocky, familiar terrain against the overwhelming, swirling beauty of a gas giant's atmosphere. To an observer, the union of these two worlds might evoke a sense of awe and humility, revealing the universe's capacity for both violence and splendor. Every glance toward the colossal planet would be an act of wonder, a reminder that within the chaos of storms and gravity's pull lies a profound, haunting beauty, an eternal dance of light and shadow, of scale and perspective, forever reshaping the way we see existence itself. As we look up at this cosmic dance, imagining Earth as a humble moon circling a vast gas giant, the scale and perspective shift before our eyes. The immense, swirling clouds of the giant planet cast shifting shadows across the tiny blue world below, an exquisite reminder of our place in this vast universe. The gentle pull of gravity would make every movement feel delicate yet profound, a testament to the universe's intricate balance and beauty. This vision awakens a sense of wonder. How fragile and remarkable our home truly is amid the cosmic ocean. It's a humbling spread of light and shadow, a dance of gravity and atmosphere that sparks the imagination and stirs the soul. We're reminded that there's always more to discover, more to contemplate, in this infinite universe. If this glimpse into a universe of possibilities stirs your curiosity, stay tuned. We're only beginning to unravel these cosmic mysteries, and captivating journeys lie ahead. Together, let's continue exploring, dreaming, and marveling at the universe's endless wonders. Because in the grand dance of the cosmos, our story is just one shimmering note waiting to be heard.